Hi everyone, welcome to this YouTube channel. Today we are providing solution to WAEC May June 2024 alternative A physics practicals. So we're looking at the live questions. Now we are going to look at question number 1. So you can see the diagram for the question. Have a stream balance, you have masses. The first mass in water, the second mass in the liquid L. So let's go straight to the question. So you're provided with a rotor stand, a spring balance, masses, a beaker containing water, another beaker containing a liquid labeled L, and other necessary apparatus. I suspend the mass M equal to 20 grams on the spring balance and measure the weight in air, WA in Newton. I immerse the suspended mass completely in water and measure the weight in water, WW in Newton. Evaluate UL equal to WA minus WW. WA is the weight in air, while WW is the weight in water. I immerse the suspended mass completely in the liquid L of the same volume with water and measure the weight in liquid as WL. Evaluate U2 equal to WA minus UWL. WA is the weight in air, WL is the weight in the liquid L. If you repeat the procedure for M equal to 40 grams, 60 grams, 80 grams, and 100 grams, respectively. In each case, evaluate WA, WW, UL, WL, and U2. Then V, tabulate your readings. Then VI, plot a graph of UL on the vertical axis and U2 on the horizontal axis, starting both axes from the origin 0, 0. Question VII, determine the slope S of the graph. Then VIII, evaluate K equal to 1 over S. And then IS, state the precautions taken to ensure accurate results. Then question BI, state Archimedes principle. Then BII, state two differences between density and relative density. So let's now go to the solutions. So have a table of value provided for that experiment. Serial number means the number of the experiment 1, 2, 3, 4, 5. Then the masses given 20 grams for the first experiment. So let's just, and then 20 grams for the first experiment. Then the weight in air 0.20000 Newton. Look at the subheading. WA, weight in air. WW, weight in water 0.1750 Newton. That's WW. WL, which is weight in liquid L, 0.1800 Newton. All values recorded to 4 SF, 4 significant figures. Then UL means the upthrust in the liquid L, which is WA minus WW. That gives us 0.02500 Newton. U2, okay, the first UL is upthrust in water. That is 0.02500 Newton. Then U2, upthrust in liquid L, which is WA minus WL. Remember that this one is WA minus WW. That is the upthrust in water. Then U2, The up thrust in liquid L, WA minus WL in Newton is 0.020 Newton. So this is for the 20-gram mass. We'll now move to the 40-gram mass. So experiment number 2. For the 40-gram mass, the weight in air is 0.4000 Newton. The weight in water is 0.3500 Newton, all values to 4 SF. The weight in the liquid L is 0.3600 Newton. Then the up thrust in water, which is UL, WA minus WW, is for the 40-gram is 0.0500 Newton. Then the up thrust in the liquid L, which is U2, is 0.04300 Newton, all values to 4 SF. So let's go to the 60-gram mass. Now, for the 60-gram mass, the weight in air is 0.600 Newton. The weight in water, WW, is 0.5250 Newton. The weight in liquid L is 0.5400 Newton. The up thrust in water, that is UL, is 0.07500 Newton. The up thrust in the liquid L is 0.06300 Newton. We'll now go to the 80-gram mass. For the 80-gram mass, the weight in air, WA, is 0.8300 Newton. The weight in water is 0.7300 Newton. The weight in liquid L is 0.7200 Newton. The up thrust in water for the 80-gram mass is 0.1300 Newton. The up thrust in the liquid L is 0.08300 Newton. That is for the 80-gram mass. We'll now go to the 100-gram mass. Now for the 100-gram mass, the weight in air is 1.000 Newton. The weight in water is 0.8700 Newton. The weight in liquid L is 0.9000 Newton. The up thrust in water is 0.1300 Newton. The up thrust in liquid L is 0.1300 Newton. All values to 4 SF. All values to 4 significant figures. You can see all of them. Then you can see the values for the up thrust. So we'll now go to the graphing. We are told to plot the graph of UL, that is the up thrust in water in Newton, against U2, that is the up thrust in liquid L in Newton. So you can see the graph obtained. Our scale on the vertical axis, that U axis, we choose a scale of 4 cm to 0.05 unit. 4 cm means 2 buses. So look at the origin 0. After every 2 buses, 0.05, 0.10, 0.15, 0.20. Then on the horizontal axis, U2 axis, we choose a scale of 2 cm to 0.02 unit. So we now have 0. After each bus, for each bus 0.02, 0.04, 0.06, 0.08, 0.10. We have a perfect graph. All the points, almost all the points are in the straight line. There are 5 points plotted. 4 of them are in the straight line, while 1 is out of the straight line. Taking our slope, we took our slope from the 4th point and to the first point. At the first point and the 4th point on the graph, we took our slope. So let's go to the slope. So the slope is change on U axis, UL axis all over change on U2 axis, which is going to be 0.10 minus 0.025 all over 0.08 minus 0.02. And that gives us slope, gives us 0.075 over 0.06. That gives us slope of 1.25. That is question VII. Then question VIII, the 8th question says we should find K as 1 over S, 1 over slope. So 1.25 gives us 0.80, and that is the relative density of L, that is kerosene, that relative density. So showing that our experiment is very accurate. Question IS, we are asked to state the precautions. The precautions: 1, I ensure that I avoided errors due to parallax in reading the spring balance. That's the first precaution. Second, I ensure that the masses were totally submerged in the liquids before taking readings. So that the precautions. Question BI says, state Archimedes principle. Archimedes principle states that, quote, when an object is totally or partially immersed in a fluid, it experiences an upthrust which is equal to the weight of the fluid displaced. So that's the Archimedes principle. When an object is totally or partially immersed in a fluid, it experiences an upthrust which is equal to the weight of the fluid displaced. Question BII says, two differences between density and rate density. Density is the mass per unit volume of a substance. Rate density is the ratio of the density of a substance to the density of water. That's the number one difference. Number two, the SI unit of density is kilogram per meter cube. The rate density is dimensionless. That means it has no unit. Question number 3 is on electricity. So we can see that diagram. Resistance RS, the value of that resistance is 1 ohm. You can see the uniform length of wire L of 100 cm. You can see the galvanometer, you can see the jockey, you can see the meter bridge, and you can see the balance point P. Then have the length LS and LY of two different wires. In this experiment, we're making use of a constantan wire as a LS, copper wire as a LY, because the instruction says provide two different wires. And the wires we're using are wires meant for meter bridge experiment. The standard wire meant for meter bridge experiment, 18 ampere watt. So we have the cell, that is the battery of EMF, then the key, and then the rheostat in the diagram. Go to the question that says you are provided with two resistance wire labeled A and B, standard resistor RS, which is 1 ohm, meter bridge, cell of EMF E, key, rheostat RH, galvanometer, and other apparatus. Use the circuit diagram as a guide to perform the experiment. 1. Connect ROS in the left-hand gap of the meter bridge. A length L equal to 100 cm of wire in the right-hand gap, and other apparatus as shown. I determine and record the balance point P on the meter bridge wire NQ. Then 3, measure and record LS equal to MP and LY equal to PQ. IV, evaluate R1 equal to LY over LS multiplied by RS. V, repeat the procedure for 4 other values of L equal to 90 cm, 80 cm, 70 cm, and cm. In each case, determine and record the balance point P and evaluate R1. Then VI, repeat the experiment with the second wire B, obtain the balance point P, and evaluate R2 in each case. VII tabulate the readings. VII plot a graph of R2 on the vertical axis and R1 on the horizontal axis. Then I determine the slope S of the graph, and then S evaluate K equal to root of S. Then SI state two precautions taken to ensure accurate results. BI state two advantages of potentiometer over voltmeter for measuring potential difference, PD. Then I define internal resistance of a cell. So let's look at the results we got after the experiment. So our results for wire A, serial number, experiment number 1, 2, 3, 4, 5. For wire of length, that is the first column, length cm, wire of length 100.0 cm. Our LS, which is equal to MP in cm, is 4.350. Our LY, which is PQ cm, is 95.65. Then our evaluation, R1, which is LY over LS multiplied by RS in ohm, is 22.00. Second set, number 2, when we use the length as of wire A as 90.00, our LS is 4.800, our LY is 95.20, our R1 is 19.83. For the third experiment, taking our length of wire as 80.00, our LS is 5.400, our LY is 94.60, our R1, the calculation LY over LS times RS is 17.70. Then taking experiment 4, taking our wire length at 70.00, our LS is 6.100, our LY is 93.90, then our R1 is 15.3939. Then the 15.39. So the fifth experiment, taking the length of wire for 60.00, our LS is 7.100, our LY is 92.90. Our evaluation of R1 gave us 13.08. So look at the subheading for wire A, LCM, LS, which is equal to MPCM, LY equal to PQCM, and RY equal to LY over LS times RS ohm unit. So every value there is given to to 4 significant figures for consistency and accuracy. So let's go to wire B. For wire B, we have also the experiment and that table for it. 1, 2, 3, 4, 5, done 5 times. The same length of wire, 100.0, 90.0, 80.0, 70.0, repeated for wire B. Then our LS, we call it LS prime to differentiate it from the former one, which was LS only. LS prime, which is MPCM, 21.10 for 100 cm. LY, which is LY prime, in this case 77.90 for the 100 cm. Then our R2, which is LY over LS times RS, to give us 3.525. Go to the second length 90.00, our LS or LS prime is 22.60, our LY prime is 7.40, our R2 is 3.425. Going to the third, 80.00, our LS prime is 23.20, our LY prime is 6.80, our R2 is 3.310 when evaluated. Then going to the fourth, wire of length 70 cm, we have a LS prime, which is 23.50, LY prime 96.50, and then R2 evaluated gives us 3.255. Going to number 5, 60.00, our LS prime is 23.70, our LY prime is 76.30, and then our R2 evaluated gives us 3.219. So we're going to plot a graph of R2 against R1. So let's go to the graphing. So for the graphing, on the vertical axis, that arrow 2 axis, we took a scale of 4 cm, that is 2 buses to 1.0 unit. And on the horizontal, arrow 1 axis, we took a scale of 6 cm to 10 unit. So to know what one line represents on the vertical axis, you divide 1 by 4 cm. 4 cm is 20 lines. Divide 1 by 20 to know what one line represents. And then to know what one line represents on this, as divide 6. Divide 10 by 6 lines is 6 buses, and 6 cm means 3 buses. Then divide 10 by 30. That gives about 0.33. So plotting our graph, look at the scale, the vertical axis 0. After 0, you have 2 buses. That is 2 buses means 4 cm, 1.0. Under 2 buses 2.0. Under 2 buses 3.0, and so 4.0, and so on. Now for arrow 2 in ohms. Then for arrow 1, where we took 6 cm, 6 cm means 2 buses. You can see means 3 buses, 2, 4, 6 for 10 units. Under 2, 4, 6 for 20 units. 2, 4, 6 for 30. So you can see that. So you see the graph plotted. You plot your graph accordingly, and then you see that this experiment is good, because out of the 5 points, we have 4 points enter the straight line. 4 points are in the straight line, and the graph has an intercept somewhere below 2. So it didn't start from origin. So you see the nature of the graph. You take your slope. We took our slope from the fifth point there, and then to a point on the straight line around 2. That will take our slope, because we cannot take a slope from the points that are plotted, because they are very close to each other. We have to take a wide range from the fifth point, which is at around this should be around 3.5. That is between 3.0 and 4.0. For around 3.5 to around 2 on the vertical axis. So let's look at the calculation of the slope. So for the slope, we have change on arrow 2 axis all over change on arrow 1 axis. That is 3.5 minus 2 all over 22 minus 2.33. That gives us 1.5 all over 19.67. Evaluating the slope gives us 0.0763. The slope has no unit, because resistance is ohms. The unit of resistance is also the ohm cancelled ohm. The one up cancels the one down. Then we have to find S. We have to find root of the slope. That's K to be equal to root of the slope. So root of the slope becomes root of 0.0763. That gives us 0.276. Then SI says precautions. Precautions 1. I ensure that the ends of the resistance wire and the jockey were cleaned. That is one precaution. Number 2. I ensure tight connections and avoided error due to parallels in reading the meter bridge. Then BI says we also state 2 advantages of potentiometer over voltmeter in measuring potential difference. Number 1, potentiometer offers higher degree of precision in measuring potential difference than the voltmeter. 2, potentiometer does not draw current from the circuit, unlike the voltmeter. Then BII says define internal resistance. Internal resistance of a cell is the resistance to the flow of current offered by materials such as electrodes and electrolytes placed between the terminals of a cell. Internal resistance of a cell is the resistance or opposition to the flow of current offered by materials such as electrodes and electrolytes placed between the terminals of a cell. So we have come to the end of this solution to May-June WAEC 2024 Physics Alternative A Practical. Stay connected to the channel. If you're not subscribed to the channel, kindly tap on the subscription bell below the channel's name, best science brand, and the video is playing. Tap on it and get connected and get subscribed to the channel. Thank you for your time.